This review problem asks us to solve the equation sine squared minus cosine squared equals 1. One approach to do so is to realize that sine squared minus cosine squared is almost the trig identity for cosine 2x. It's just off by a minus sign. With that in mind, let's multiply both sides of this equation by minus 1. On the left-hand side, we'll have cosine squared x minus sine squared x. And on the right-hand side, minus 1. Then cosine squared minus sine squared is exactly the trig identity for cosine of 2x. And cosine is equal to minus 1 if we think of the unit circle, precisely when the input is equal to pi, or we add on to it a multiple of 2 pi, where here n can be any whole number. Dividing by 2 gives us that x is equal to pi over 2 plus n pi, and here n is any whole number. So we'll say dot 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 minus 2, minus 1, 0, 1, 2, and so on. Or an alternative approach here is to think in terms of your Pythagorean identity. If we subtract sine squared from both sides, we would have minus cosine squared x equals 1 minus sine squared, where 1 minus sine squared is simply cosine squared. So minus cosine squared x equals cosine squared x, and 0 is equal to 2 cosine squared x. And the only way this can be true is if cosine itself is equal to 0. And if we think in terms of the unit circle, cosine is equal to 0 at two types of places. It's equal to 0 at pi over 2 plus a multiple of 2 pi, or at 3 pi over 2 plus a multiple of 2 pi. So we have x is equal to pi over 2 plus 2n pi, or x is equal to 3 pi over 2 plus 2n pi. And if we combine these two together, note this is exactly the same thing that we saw above. This is x equals pi over 2 plus n pi, where once again here n is any whole number. So minus 2, minus 1, 0, 1, 2, and so on.